Hello, my name is Cameron Jordan, and I'm a PhD student at The Ohio State University. My work is on the kinetic degradation of cannabinoids and a non-destructive approach to cannabinoid quantification. My lab has already done work on Fourier transform near-infrared spectroscopy as a non-destructive approach to monitoring for cannabinoids. Now we are wanting to expand the range of analyzed cannabinoids and test the limits of detection of our technology. The objective of this study was to calculate the kinetic parameters of cannabinoid degradation and non-destructively monitor for these cannabinoids in hemp. A composite hemp sample was made in a lab blender and aliquoted into microcentrifuge tubes. The tubes were then stored at different temperature points in 1-week intervals for 5 weeks. After the incubation time, all samples were scanned using a handheld FT-NIR spectrometer. The reference cannabinoid values were determined by LCMS. The data were then correlated by chemometric methods such as partial least squares regression or PLSR. The data for each cannabinoid was fit to the Arrhenius equation, and the activation energy was calculated. The acidic cannabinoids had a lower activation energy than the neutral cannabinoids, showing that decarboxylation is the primary path of degradation. The data shows cannabinoid degradation reactions are first and second order. The spectral data were correlated with the LCMS reference data by PLSR. The RCV value is related to the fit of the multivariate model, and the standard error of cross-validation is the error in making a prediction using this model. The regression vector shows the important regions of variations in the spectra for each cannabinoid. In this case, the regression vector shows variation in the CH2 stretching band, which is related to lipids. More data is needed on the kinetic degradation products of hemp. These products can be determined by taking an untargeted approach. A larger sample size with more genetic variation would be beneficial for this model. FT-NIR technology can be used to accurately and sensitively monitor the cannabinoids of hemp.